This was once Israel's most famous beach. Tourists from around the world came here to float in the Dead Sea, the saltiest body of water on Earth, the lowest point on the planet's surface. Look at it now. The water? It's gone. The Dead Sea isn't just retreating, it's collapsing. Every single year, the water level drops 1.1 meters, that's 3.6 feet. Since 1970, the Dead Sea has lost 37 meters of depth. That's a 12-story building. And it's leaving behind something terrifying: 7,000 sinkholes. Massive craters that open without warning, swallowing roads, agricultural fields, even buildings. Portions of Highway 90, the main road along the Dead Sea, have literally vanished into the earth. Now, you might be thinking, that's tragic, but I don't live in the Middle East. Why should I care? Here's why. The Dead Sea will completely evaporate by 2100 without intervention. Scientist prediction, 2021. Similar crises happening now: Great Salt Lake, Utah; Aral Sea, Central Asia; Lake Chad, Africa. 1 in 3 major lakes and rivers worldwide are shrinking due to over-extraction and climate change. What's happening to the Dead Sea is a preview of what's coming to water bodies near you. And for 150 years, engineers have tried to save it with one of the most ambitious megaprojects ever conceived: a canal connecting the Red Sea to the Dead Sea. A 180-kilometer pipeline dropping 400 meters in elevation, generating hydroelectric power, producing fresh water, and supposedly saving the lowest place on Earth. They've signed treaties, raised billions, celebrated groundbreakings, and it still hasn't been built. Welcome back to Grand Structures. Today, we're investigating the rise and fall of the Red Sea-Dead Sea Canal, one of history's most politically complex infrastructure projects, and why, after decades of promises, it might already be too late. To understand why the canal failed, you need to understand what's killing the Dead Sea. And contrary to popular belief, it's not a natural process. It's human-caused, and it's accelerating. The Dead Sea has no outlet. Water flows in, primarily from the Jordan River, and then evaporates. That's it. For thousands of years, this system was balanced. Inflow roughly equaled evaporation. The sea level fluctuated naturally, but stayed stable. Then, in the 1960s, everything changed. 3 things started draining the Dead Sea dry. Killer number 1. The Jordan River diversion. In 1964, Israel completed the National Water Carrier, a massive water pipeline system that diverts water from the Sea of Galilee and the Jordan River to Tel Aviv, Jerusalem, and the Negev Desert. At the same time, Jordan, Syria, and Lebanon built over 50 dams on tributaries feeding the Jordan River. The result? The Jordan River, which historically delivered 1.3 billion cubic meters of water per year to the Dead Sea, now delivers only 100 million cubic meters. That's a 92% reduction. The mighty Jordan River is now, in many places, a polluted trickle you can step across. Killer number 2. Industrial evaporation. The second killer, mineral extraction. Companies pump water out of the Dead Sea into massive evaporation ponds, you can see them from space, to extract potash, bromine, and magnesium for fertilizers and cosmetics. Israel's Dead Sea Works evaporates 160 million cubic meters per year. Jordan's Arab Potash evaporates 100+ million cubic meters per year. Combined impact, 23% of total Dead Sea water loss. These companies argue they're not the main problem, and they're technically right. Even if all mineral extraction stopped tomorrow, the Dead Sea would still drop 0.85 meters per year instead of 1.1 meters. The main culprit is the Jordan River diversion.
And finally, the region is getting hotter. Summer temperatures at the Dead Sea now regularly exceed 50 degrees Celsius, 122 degrees Fahrenheit. The evaporation rate is 1.1 to 1.2 meters of water depth per year. In the brutal heat, the exposed surface evaporates faster than ever. Current Dead Sea water balance. Inflow, approximately 100 to 200 million meters cubed per year, Jordan River plus rainfall runoff. Outflow, evaporation plus industrial, approximately 700 million meters cubed per year. Net loss, minus 500 million meters cubed per year. To stabilize the Dead Sea at its current level, you'd need to add 900 million cubic meters of water per year. That's 900 billion liters. Every single year, forever. But here's where the crisis gets truly dangerous. As the water retreats, it exposes ancient salt layers buried underground. Fresh water from winter rains flows down the mountains onto these exposed plains, and when fresh water meets salt, it dissolves it. Massive underground cavities form. The ground above becomes a thin crust, and then, without warning, it collapses. In 1990, there were 40 sinkholes around the Dead Sea. Today, over 7,000. They're appearing at a rate of 1 per day. Some are 25 meters deep and 80 meters wide. Date palm fields have been swallowed, buildings abandoned, portions of Highway 90 closed indefinitely. En-Gedi, once Israel's premier public beach, has been closed for 5 years, not because the water is unsafe, because you literally can't reach it without crossing a sinkhole minefield. The hotels that remain, they're built next to artificial evaporation ponds from the mineral companies. The actual Dead Sea is half a kilometer away. So, how do you save a dying sea? For 150 years, the answer has been the same. Build a canal connected to another sea. The idea was first proposed in the 1850s by British naval officers looking for ways to bypass the French-built Suez Canal. They didn't realize the Dead Sea was 400 meters below sea level. When they figured it out, they had a new idea: use the elevation drop to generate power. At the end of the 19th century, Theodor Herzl, the father of modern Zionism, proposed a Mediterranean Dead Sea conveyor. Seawater would flow downhill from the Mediterranean, spin turbines to generate electricity, and power a thriving industrial economy in the Jordan Valley. It was never built, too expensive, too complex, but the dream never died. Every few decades, someone would dust off the idea, update the engineering, and declare, "This time we'll do it." The modern version, the Red Dead Sea Water Conveyance, was born after the 1994 peace treaty between Israel and Jordan. King Abdullah II of Jordan called on Israel to help save the Dead Sea. This launched a three-way partnership: Israel, Jordan, and the Palestinian Authority. In 2002, a full feasibility study began, funded by the World Bank. The plan was elegant. The Red Dead project design. Intake: pump seawater from Gulf of Aqaba, or Red Sea, on Jordanian side. Uphill pump: lift water 230 meters to start of the pipeline. Desalination: build plant in Aqaba, produce 80 to 100 million meters cubed of drinking water. Brine pipeline: 180-kilometer pipeline carrying reject brine plus seawater gravitationally to Dead Sea. Hydroelectric plant: generate power from 400-meter drop to Dead Sea level. Water delivery: 400 million meters cubed of brine plus seawater replenishes Dead Sea annually. Estimated cost: total $10 billion, full project. Phase 1, pilot, $1.1 billion. Israel's share, $1+ billion. No economic benefit, only strategic. Here's where this story gets frustrating. Over the next decade, there were multiple signing ceremonies. December 2013, Israel, Jordan, PA sign agreement in Washington. February 2015, bilateral water cooperation deal signed. July 2017, trilateral water deal announced with U.S. envoy present. Politicians smiled for cameras, World Bank celebrated, donors pledged money, US $100 million, EU 160 million euros in loans, Japan $20 million, Italy $2 million. Everyone said construction begins in 18 months. Nothing happened. Years passed. Donors grew frustrated. Environmentalists raised alarms. And Israel never approved the funding. Problem number 1. Israel had no incentive. Let's be brutally honest. The Red Dead Canal made no economic sense for Israel. The country would pay $1 billion for a project that delivers zero drinking water to Israel, it all goes to Jordan, generates zero electricity for Israel, used to pump water and run desalination, provides minimal benefit to the Dead Sea, only slows the decline by 1/3, doesn't stop it, and only strategic benefit keeps Jordan politically stable by solving their water crisis. Israel was being asked to write a $1 billion check to save Jordan from collapse. And while that has strategic value, preventing regional instability, it's a hard sell domestically, especially when Israel has its own water needs and the Dead Sea will keep shrinking anyway. Problem number 2. Jordan couldn't afford to wait. Jordan is one of the most water-scarce countries on Earth. They extract groundwater at twice the rate it can naturally recharge. Their aquifers are depleting. By some estimates, Jordan will face catastrophic water shortages by 2030. Remember the Syrian drought from 2006 to 2011? It's credited with helping spark a Syrian civil war. Farmers moved to cities, unemployment spiked, food shortages followed. Jordan's government looks at Syria and thinks, that could be us. So Jordan needs water now, not in 10 years after construction, not after environmental studies, not after Israel's budget approvals. Now. That's why Jordan ultimately walked away. And then there are the environmental concerns that no one wants to talk about publicly. Mixing Red Sea water with Dead Sea water could be catastrophic. The Dead Sea has 34% salinity, 10 times saltier than the ocean, with a unique mineral composition: magnesium chloride, calcium chloride, potassium chloride. The Red Sea, normal seawater, sodium chloride. When you mix them, you get gypsum precipitation, white plumes forming cloudy layers, algae blooms. Nutrient-rich Red Sea water plus sunlight equals massive algae growth. Color changes. The iconic blue Dead Sea could turn greenish or milky. Unknown ecological impacts. No one really knows what happens long-term. The mineral extraction industry, Dead Sea Works and Arab Potash, warned that this could destroy their business. These companies generate billions in revenue. If the water chemistry changes, mineral extraction might become impossible.
In June 2021, Jordan officially pulled the plug. After 20 years of studies, billions in pledged funding, and multiple signing ceremonies, it was over. Jordan's official reason? Lack of Israeli interest. Translation: Israel never approved the budget. And after 2 years without a functioning government, 2019 to 2021, it became clear Israel wasn't going to. Jordan announced they'd build their own desalination plant in Aqaba, without Israel, without the pipeline to the Dead Sea, without the hydroelectric component. Just a straightforward national water project. The Dead Sea, left to die. Alternative number 1, restore the Jordan River. There's one solution that environmentalists have advocated for decades: restore the Jordan River. Stop diverting 90% of its flow. let water reach the Dead Sea naturally. This would require Israel reducing extraction from Sea of Galilee and Jordan River, Jordan, Syria, Lebanon closing or modifying dams, massive investment in wastewater recycling and desalination to replace lost agricultural water. Cost $3 to $5 billion. Likelihood politically impossible in current climate. EcoPeace Middle East, an environmental NGO, has pushed this plan for years. Their argument, it's cheaper than a canal, environmentally superior, and addresses the root cause. But it requires regional cooperation at a level that doesn't exist. Alternative number 2, Mediterranean Dead Sea Canal. In May 2024, Israel's Environment Ministry unveiled a new plan. Forget the Red Sea, connect the Mediterranean to the Dead Sea. The Med-Dead Plan. Intake at Haifa Bay, northern Israel coast, 180-kilometer pipeline through Jordan Valley, desalination plant powered by hydroelectricity from elevation drop, 268 million cubic meters of desalinated water for Jordan, 400 million cubic meters of brine to the Dead Sea. Cost $2.7 to $4 billion. Timeline operational by about 2045. Status proposal phase, no funding approved. This avoids Jordanian territory entirely, which removes political complications, but it's still massively expensive, environmentally risky, and 2 decades away. Alternative number 3, do nothing, let it die. And then there's the option no one wants to say out loud, let the Dead Sea go. Some scientists argue the sea will eventually stabilize at a lower level where evaporation equals inflow. The surface area shrinks, evaporation decreases, equilibrium is reached, maybe at negative 450 meters, maybe negative 500 meters. It becomes a smaller, hypersaline lake. The tourism industry adapts. Hotels already rely on evaporation ponds, not the actual sea. The mineral companies keep operating. They actually benefit from higher salinity, and the billions saved from not building a canal invest in desalination, which Israel has already mastered. It's the cynical, economically rational option, and honestly, it's probably what's going to happen. So why did the Red Dead Canal, a project with 150 years of history, international support, and billions in pledged funding, ultimately fail? The hard truths. Economics, Israel had no financial incentive to fund it. Politics, regional cooperation requires trust that doesn't exist. Environment, the ecological risks were never fully understood. Alternatives, desalination got cheaper. The canal became obsolete. Urgency mismatch, Jordan needed water now. The project needed decades. The Dead Sea isn't unique. The Great Salt Lake in Utah has lost 73% of its water since 1847. The Aral Sea is 90% gone. Lake Chad has shrunk 95%. Climate change and over-extraction are killing water bodies worldwide. And everywhere, governments propose mega projects, canals, pipelines, massive pumping schemes. They hold press conferences, sign treaties, and then nothing. Because these projects require political will across multiple countries, sustained funding over decades, acceptance of environmental trade-offs, and faith that it will actually work. The Dead Sea taught us when all 4 aren't present, even the most ambitious infrastructure dreams become diplomatic theater. The Dead Sea is going to keep dropping 1 meter per year. By 2100, without intervention, it could be completely gone, a dry, salty crater at the lowest point on Earth. The Red Dead Canal could have slowed that decline, not stopped it, just slowed it by maybe 30 to 40%. For $10 billion and decades of construction with massive environmental risks. Was it worth saving? Absolutely. Will it be saved?
Probably not, because sometimes the economics, the politics, and the engineering just don't align. And when they don't, nature wins. Or, in this case, nature loses. Here's my question for you. If your country faced a similar choice, spend billions on a mega project to save a dying landmark, or invest that money in practical solutions like desalination, what would you choose? Let me know in the comments. Until then, stay curious, stay skeptical, and remember, the biggest infrastructure projects aren't always the ones that get built. Sometimes the most important ones are the ones we choose not to build.